Um, that song was a bit appropriate. I think Ben invited me because I'm here as a little bit of hope because I'm just a simple mechanical engineer. But this story is about how you can use AI. You don't have to be an expert in it, and you can kind of use it. I've never been comfortable with that idea of being called an expert either. I remember the first time I got a call from someone in the government. They said, "Grant, do you want to be on this expert ICT panel?" And I politely declined. I figured a minimum requirement is to know what ICT stands for. Um, I do now. Do know what AI stands for, and I think I could even spell it. So this project's got a little bit of an unusual story as to how I got into it. So it started with the Christchurch earthquake, and as a result of that, I ended up moving to a little town called Akaroa, and we've got this house surrounded by bush. I don't expect any sympathy for that. It's quite a nice place to live. But the real estate agent never told me it was infested with rats and possums. They were literally living in the ceiling. And so, like lots of good Kiwis, went about doing a bit of trapping. And over the next couple of years, I'm sure the bird volume went up. And I was like, man, that's kind of cool. But then the engineer in me started to kick in, and I started to try and find out a little bit more about what the project's all about. And so we have this kind of simple thing where if it's a good natural environment, you've got this cacophony of birdsong, and if not, you don't. And so when I dug into the problem, I was a bit horrified. I don't know how many of you know, but depending on how you measure it, New Zealand's either the worst or the second worst place in terms of number of species already endangered or still in decline. So forget about the places that are chopping down forests and poaching things, we're worse, which is horrific. And it's not because we don't care, it's because we evolved for 70 million years without rats, stoats, and possums, and they're basically just eating our native wildlife. So it's quite a horrific problem. And then the engineer in me started to kick in because whenever the state of the art is tipping poison out of a bucket or from a helicopter or variations on mousetrap, I think there must be a better way to do it. So our little way of attacking it has got two key things. So one is that it's based on Moore's law. So if we make it digital, it's going to get twice as good or half the price. And then the other one is it's all open source. We figured we're not intelligent enough to do the whole thing, so it's all completely open and people can chip in and get into it. So the first little project we had was just to have a simple tool, so a little smartphone app, so we could download the sound every hour and then upload it to the cloud so that we've got an objective way we can see, measure the cacophony. Is it getting better or isn't it? I was kind of a bit sick of these anecdotal stories. And this is the sort of thing that our computers are good at. So obviously to measure the cacophony, we call it a cacophonometer. Um, and when we weaponize it, we'll call it a cacophonator. Um, so that's kind of how we started. And then I couldn't help but put my geekish brain on and think how else we could use technology to make trapping better. So we think we can make it 80,000 times better. And this has actually destroyed my career as an inventor because I've got a list of 200 things and none of them I can make things 1,000 times better, let alone 80,000 times. So let me explain. So the standard way you do trapping at the moment is you use food, and the animals can only smell 3 to 5 meters, but they can hear at least 10 times as far, if not further, so you can cover 100 times the area. Um, Instead of the bait getting eaten, you can have it digitally powered, so you can last for a lot longer. You can have one trap that can do all the different animals instead of different traps. And then the thing that horrified me is we put some cameras in front of existing traps, and they're getting kill rates as low as 1%. So we'll see 100 possums for every one that goes in. So the engineer in me goes, oh, there's lots of opportunities to make that a little bit better. So we're not keen on reinventing the wheel too much. So we're just using simple off-the-shelf technology, mostly. And so this is just to show you how stupidly simple it is. It's just a little Raspberry Pi in there with a thing that can talk to the cloud, and it's got a heat camera. So that's kind of the basis of what we use for how we identify the animals. So we had to create a tool where we could see all the animals that are out there. So it had to start instantaneously so that we can see what's out there, because we even had fast hedgehogs walking in front of existing cameras and they missed them. They just didn't start fast enough. And then we were using heat cameras because even if you use an IR camera with light, it can scare some of the animals. So this particular example, do you see what he left there? Oh, he didn't. It was a bit hard. But when it's based on heat, it actually makes it really easy to identify because most of our predators are at night. And so basically, in order to get rid of all the predators, you have to be able to see them. So the state of the art at the moment is actually little chew cards and tracking tunnels. So they put them out and they go and look at the teeth marks and footprints and see if they can work it out. So Obviously, if we can use some digital technology, it'll be a bit better. And then we don't want to look through all those videos. So obviously, artificial intelligence is going to be a great way to do it. This just shows how our classifier works at the moment. So on the left-hand side is the raw video, and then we get rid of the background, put a box around it. So the little number at the bottom is a real-time thing where it's trying to work out what animal it is, and the number at the top is when it's got worked out what it is. So basically, we've got a little device that can tell the difference exactly between the difference between rats, stoats, and possums. So instead of manually putting all these cue cards and things out, we've got a device that can tell you exactly what turns up where and when, way more efficiently than any other device. So that's the stoat there that pretty much they just can't tell any other way where there are stoats there because they're too fast for the other cameras. So we've got this device now that can work out exactly what's out there. That's just a little slide for anyone who's interested in some of the techie stuff. I don't really understand that exactly, but now one of the cool things about digital lures is one of the hardest things is to get the last predators. And when you're getting the last predators or there's a re-invasion, there's lots of food everywhere, so food works even worse. But after you've got a full belly, you know, what's next on your list? A little bit of, social interaction. And so we think you can mimic social sounds, and we've got some good examples that it looks like it should work. And one of the reasons I particularly like, there's lots of reasons digital lures are great, because you can get as adaptive as you like. You can say, we're in a beach forest in autumn after a bit of rain, and we know there's a large possum around, so you can play a different sound. But the reason I really like this digital lure approach is people say, oh, Grant, what are you working on? I can say, I'm thinking quite a lot about possum erotica. And it can stop a conversation. So the whole point of this is suddenly we've got a digital platform that as soon as anyone works out anything slightly better, it can get better and evolve, and that's really quite a powerful thing, because these are very clever creatures as much as, we. But if we can't get rid of these, then we certainly don't have to worry about this. So obviously the next sort of thing where this goes is, this is a little camera. Now if you look closely, you'll see the production quality of this is not quite like the Microsoft videos. So this is obviously tracking. I did tell him to get rid of his jandals, but he didn't. So this is also showing that we can't tell. You can see it's not working out that it's a remote control, radio control car. We probably won't teach it to learn to find feral remote. But so that was just an example where you can actually show how the camera can move around to track the animal. Because one of the things is quite often they just walk straight past the traps. And then I'll show you this next slide, but you just have to breathe in a little bit and relax. Okay? So I purposely got something that was a little bit imposing. So we're not going to set up a machine gun to shoot them or anything silly like that. But what's quite interesting is we're working with some folk at Lincoln University, and they've worked out that if you put poison on a predator, then they'll lick it off. They're all groomers, so they'll lick off whatever's on them. So we've come up with the idea of having a paintball of poison that we can fire at the predators. So potentially we can identify, lure, and then kill all predators with a little device that can fire paintballs at them. And I quite like my job. Before Christmas, I had to walk with this radio control car down the street to a software engineer guy, and I was like, man, this is such a cool job. So the interesting next steps for the artificial intelligence is we've got to improve it a little bit. We can actually get the artificial intelligence running in real time, so it can actually see what's happening. So that sort of stuff that used to be, when I first looked at it a couple of years ago, really hard, is now just so easy. It's amazing. It's not completely simple, but it's getting there. And then we can get adaptive and learn the best lures so that we can get better all the time. So we've got to get better faster than the predators do. And then we can also do something interesting. Where we were testing some of these sound lures, what would happen is we'd play a possum booming away, and then it didn't attract it in, but this possum would start booming away back at us. So you could actually identify at a distance if there's a possum in the area. So this was quite funny because I had this on repeat, and I came out 3 hours later and our thing's booming away, and this thing's trying to boom back, but it's got a sore throat. Maybe that's another tool. But it means what we can do is we can potentially ping some sounds, listen, see what's out there. Depending on that, we can then play a different one, lure it in, identify it, track it. Away we go. And then the way this will actually work is people go, oh man, that's way too expensive. But if you think about it, these things don't have to stay there for very long. You can have a line of these things. They're there for a week. They identify, lure, kill everything, and then you move them on. And so you can have the line of things sweeping through a whole area, get rid of the whole lot, and leave a couple there to identify what's going on. And then we're working with some very cool people at University of Canterbury who want to put these on quadcopters, which would be kind of cool. So you could potentially do it in areas where you couldn't do it at the moment. So we've got some great supporters. I pull out Next Foundation and Spark have been absolutely fantastic. Free data, free hosting, a bunch of cash, expertise. They've just been absolutely fantastic. And the interesting thing there is there's no government support. We're a bit too radical for government at the moment, but oh well. We're just getting on and doing it, and it's looking quite promising. So this stuff, it does sound like sci-fi, but it's not really. So Moore's law, as you know, if you make it digital, it gets half the price, twice as good. So we did a little calculation. Government wants to be predator-free by 2050. You know how much progress we've made in 10, 20 years. It's not going to take 32 years. We'll do it way before then. And then the interesting thing about exponential is you get, when you start, it's very disappointing. So we go to apply for some of these things and they say, well, how many possums have you killed? And we're like, well, not many. How many are you going to kill next year? Probably not many. But we're on a trajectory where you can obviously do quite well. So this is all completely open source, and it's a really powerful way of working that I hadn't really been familiar with, but it makes you feel good about humanity, really. We just say, here, we're doing this, and then people just start chipping in. And we've got some really clever people all around the place that are chipping in. So if anyone wants to chip in, you're most welcome to. And then we've got some really cool data sets that if anyone wants to play around with any AI stuff, it's all open and free. So you're most welcome to use it. So I can imagine a scenario where you've got these devices that can identify, lure, and kill everything, and you've got them sitting there in lines of these things that drones are moving up through the area, through areas to get rid of absolutely all predators. And then we will get our cacophony of birdsong and all the other fauna back, and it'll be absolutely fantastic. And that is a cool way that you can use AI for a very New Zealand project. Thank you.